Hey everyone, welcome back to another episode with OneClass. My name is Bassam, and today we're going to be going through some math questions at the high school and university level. I'm an engineering graduate, and the following questions are going to be shown on the screen right here. Okay, so this is the first question. Okay, so question number 1. Okay, so what I'm going to do here is I'm going to go through what the junior tutor proposed as a solution, and then we're going to verify that solution by going through step by step on how to do it. So here the question is asking division rule derivatives. So we want to talk about kind of what is the division rule when we're taking derivatives. So taking a look at the junior tutor, a rule that is used to find the derivative of a quotient function. So it's sometimes also referred to as the quotient rule. And it's as follows. It shows the following formula. So the derivative of some function f at x divided by some function g at x is as follows. The derivative of f at x times g at x minus the derivative of g at x times f at x. This is all divided by the function g at x squared. So here the junior tutor goes through an example, so we can see x ln x, and so on. So we'll go through the same example over here to double check. Let me just double check something over here, so you guys are seeing what I'm seeing. Okay. Okay, so we're saying that the derivative of some function f at x divided by some function g at x equals the following. So we said the derivative of the first, so I'll just say f prime, times the second, so times g, I'll put a dot here for times, minus the derivative of, I guess, the bottom, so g, times the first, which is f at x. So times f divided by essentially g squared. So this is kind of just short form way to write the same thing that's written over here. So let's go through an example of how this would work. So here if we had the function x over ln x, we can see that f at x here is just x, and g of x is ln x. So it could be any other function, but in this scenario we're given x over ln x. So we'll take the derivative of that. So the derivative of d dx of f at x over g of x, which is just this up above, this would give us, so we know it's the derivative of f at x. So in our scenario, x is equal to f at x, so we know the derivative of that is just 1, multiplied by g at x. So we're using this equation up here, multiplied by g at x. So here is just ln x, so we know it's 1 times ln x minus the derivative of g at x, so the derivative of ln x, and the derivative of ln x is just 1 over x. So this is just the derivative of ln x is just something you should memorize, which is just 1 over x, and then multiplied by f at x, which is over here, and that's just x for us, divided by g at x squared, so ln x squared. So this simplifies out to equal ln x, so the first term is just ln x minus 1, because the x's cancel, over ln x squared. So we'll say ln x and this is squared. So here we can see we obtained the correct answer, and the junior tutor's answer is also correct. So we'll say great job. Answer is correct. And we'll mark this answer as correct. I'm just going to clear the board. Okay, so on to question number 2. Okay, so here we're asked, a dart thrower randomly throws a dart at a dartboard. If the probability that the dart hits the dartboard on each throw is 0.4, what is the probability that at least one of the first 2 throws hit the dartboard? So we have 2 throws, so this is a key in the question. At least one of the first 2 throws hits the dartboard, and we're given 5 options over here. A 0.84, B 0.16, C 0.36, D 0.64, or none of the above. So this is kind of just the statistics probability question. Let's go through with the junior tutor answer. So the probability is 1 minus the probability that no darts hit the board in 2 tries. So here the question is asking, what is the probability that at least one of the first 2 throws? So here the answer thinks about it in the opposite way. So in a scenario where none of the darts hit the board, subtracted by 1 is essentially this, what is defining the question. So if you take 1, which is just equivalent to 100%, minus the probability of no darts hitting the dartboard, we would end up with the probability of at least one of the first 2 throws hitting the dartboard. So if we look at it this way, so we know that a hit, the probability of a hit as defined up here, so if the probability of a dart hits the board is 0.4, so we'll say the probability of a hit, H meaning hit, 0.4. So 0.4 just represents there's a 40% chance that it hits the board. And then therefore the probability of a miss would just be 60%, which is 0.6. So just starting off with that, so we're looking at the probability of at least one of the 2 throws. So we'll say minimum of 1 hits the dartboard. So if we missed both, we know we can calculate the probability of that. So the probability of missing the first shot would be 0.6. The probability of missing the second shot is 0.6. So we just multiply 0.6 by 0.6, and we'd end up with 0.36. So I'll just write that over here. But we're not looking for the probability of missing. Of no hits at all. We're looking for the probability at least 1 hit. So it will be the opposite of this. So that's why we have the 1 minus 0.6, which is the first throw, times 0.6, which is the second throw. So we know by thinking about it this way, we're able to calculate the probability that at least one of the first 2 hits the dartboard, because in this situation this would be true. So we end up with 1 minus 0.36, and that gives us 0.64. And that's our answer. So looking at the options, we can see that D is the answer here. So let's say D. So the junior tutor proposes the correct answer. So correct. So, great job. Alright, and we'll mark this question as correct. Okay, so this is question number 3. Alright. So here we're asked to find the derivative of sine 2x. So what is the derivative of sine 2x? So I'll put this in brackets as well. Sine 2x, like that. Okay, so let's look at what the junior tutor wrote over here. So they have dy dx is equal to d as sine 2x dx. So y is just defined as sine 2x. The first step for doing this, we know that if we took the derivative of sine x, we know it's cos x, but we have the 2x, which complicates things. So essentially what you do here is you take the derivative of the outside and you multiply it by the derivative of the inside. So when I say outside, I'm meaning this, and when I say inside, I'm meaning what's inside the brackets in here. Okay, so you can see here sine 2x, the derivative of sine 2x, cos 2x times the derivative of the inside, which is just 2x. That's what we get over here. Then we can just complete this by itself. So the derivative of 2x is just 2, and that's how you get 2 cos 2x. So I'll go through this one step by step. So we said that we take the derivative of the outside. So I'll highlight that. So the derivative of this, we know the derivative of sine x is just cos x, so we'd end up with cos 2x. You keep everything the same that's inside the brackets over here. And then you take the derivative of the inside. So we'll say multiplied by the derivative of 2x. And then we end up with cos 2x multiplied by just 2, which gives us, because we know the derivative of 2x is just 2, you get 2 cos 2x. And that's how you get to the derivative solution. So you can see that the junior tutor goes through the correct steps, and the solution is correct. So correct answer. Great job. So even if you started off with any kind of sine, cos, or tan, you do the same idea. You take the derivative of the entire function, so the outside, and then you multiply by the derivative of the inside. So if this was 3x, this over here would just be 3x. If it was sine 3x squared, this over here will be sine, this would be 3x squared, and then this would be cos 3x squared. And then you just continue on and get the correct answer. So we'll mark this as correct. We'll move on to question number 4. Just going to clear the page. Alright, so question number 4. So now we're taking the integral of ln x. So we did some derivatives, now we're going to do an integral in this question. This is question number 4. So let's go through what the junior tutor did here. So the function given in the question is ln x. So this is an important integral to know. Sometimes you would memorize this integral because it's a commonly asked question, but we'll go through the steps of how to get to the answer. Excuse me. Okay, so and there is no direct method of integrating ln x. The integration of a function we need is to use integration by parts. So this is what we're going to be using to do the integral. So here we can see ln x. This is the integration by parts, and to go through the process step by step. So I'll write down the formula for integration by parts. So it will be as follows. It will be the integral of u dv equals u times v. Let me just write that again. So u times v minus the integral of v du. So u and v are just placeholder variables, and you'll see how this is useful in a second. So if we thought about the integral of ln x, we want to solve for this, what we do is we would set u equal to ln x, and we would say dv, so there should be a dx over here, will be equal to dx. So we'd set up the variables of the integration by parts formula as follows. And then we would say that du, so the derivative of u, which we set to ln x, is just 1 over x, because we know the derivative of ln x is 1 over x, dx. And then we want to also evaluate for v here. So we'd say if we integrated dv equal to dx, we would get v equal to x. And now we've defined the 4 variables, or not variables per se, but the 4 things that we need to plug into the integration by parts formula. So looking at this, kind of we've said this is u, this is v, sorry, this is dv. We kind of set it up the same way. So all we really have to do is plug in these values. So we'll say, we'll put this down here, we'll say this is equal to u times v, so it will be ln x times x, so ln x times x minus the integral of v du. V over here is x, du is 1 over x dx. So we have x 1 over x dx. And then going on, we can see that the x's cancel out, and we're left with x ln x minus the integral of dx. And you can see now how this kind of simplified down to a simple integral that we can easily evaluate for. So the integral of essentially 1 dx is just x. So we get x ln x minus x, and then we have plus c for the constant. So you can kind of see how this is useful. So right away we can't really, it's kind of difficult to evaluate the integral of ln x without kind of splitting it up into integration by parts and then ending up with this solution below. And we can see that the junior tutor obtained the same answer as shown here. So we'll mark this solution as correct. So correct answer. Great job. And we'll go to the next question. Okay, so question number 5. Okay, so there is no question here. Well, actually, I'm looking up here. How do you convert as a decimal and a percent? So I'm guessing conversion between a decimal and a percent. So let's look at the junior tutor solution to get some idea on kind of what the question is asking. So here we're given steps. So here, step 1, observe the denominator of the fraction. The denominator is a number which can be written as 2m times 5n, and m and n are non-negative numbers. Then the fraction can be converted into a terminating decimal, otherwise it is a non-terminating decimal. So they kind of give you a simple kind of trick to determine if the decimal is a terminating or non-terminating. Non-terminating means that the decimal places just go on forever. Terminating means that at some point the numbers after the decimal point stop. So divide the numerator by denominator. If the division is non-terminating or the division is too long, then the decimal expansion can be rounded up to 2 to 3 decimal places. This will give us an approximate fraction. So let's look at kind of an example here below. So 7 over 20 is one of the fractions. So if we had 7 over 20, you can see the denominator is 20, and it can be written as 2 to the power of 2 times 5. So kind of thinking about the denominator, we look at 20. We know that 2 to the power of 2 is 4, and 4 times 5 is 20. So it can be written as 2 to the power of 2 times 5. And then going back up here, I'll write this up top. So 2m times 5n. We can see that we've kind of put it in a format where this is true. Therefore, we have a terminating decimal. So if we were to plug this into our calculator, we can kind of see that this would give us 0.35, and we can see that we would end up with a terminating decimal point. So if you were kind of if you wanted to get 0.35 kind of using without using a calculator, sorry, you can kind of think about it as follows. So 7 over 20. What I usually like to do is try to get the base, or sorry, the denominator, the 20, to equal 100. So we know 20 times 5 will give us 100. So if you multiply bottom and top by 5, we'd end up with 35 over 100. And since 100 in the denominator is easier to divide into 35, we know how the decimals work here. We just shift over the decimal place twice. So 1, 2, and we'd end up with 0.35. And we know it terminates at 5. So the rest follows is just zeros. but we don't necessarily write that. But this validates that yes, it's a terminating decimal point. So let's look at another example presented by the junior tutor. So here we have 5 over 8. We look at the denominator. We know that 8 can be written as 2 to the third, 2 to the power of 3. That means we know it's a terminating decimal point. So again, we want to get 8 to equal 100%. In this case, it might be a little more difficult to do that. But I guess how you can think about it. So let me clear some space here. So if I had 5 over 8, I know right away that 4 over 8 is equal to 50%, or 0.5. That means 5 over 8 should just be a little bigger, but not that much bigger. So here, if we were to the easiest way would kind of just be plugging into your calculator, but you can see here that 5 times 20, so here they do 5 times 25 divided by 2, and they divide 125 by 2 to get, so here they kind of rearrange. Let me see here, what did they do here? So 5 times 25 divided by 2. So okay, so essentially what they did here is, if we had 5, and we know that it's 2 times 2 times 2. So 5 times 25 divided by 2. So here they multiply by 100%. Yeah, I'm not quite sure what they did here, but they did end up with the right final answer. So I guess if you split up kind of 1, this is kind of a better way to think about it. Right, so if you split up 1 into divided by 8, you know that if you did 1 divided by 10, you would get 0.1. And then essentially 1 divided by 8 is 0.125. If you multiply this by 5, you would end up with 0.625. So if you multiply this by 5, you would end up with 0.625. And then finally, here we have 3 over 5. This is another one that can be written as in this 2 to the m times 5 to the n. So we know it's a terminating decimal point. 3 over 5 is just 0.6. If we think about how many times does 5 go into 100, it would be 20 times. So 20 times 5 gives us 100. Therefore, we can multiply top and bottom by 20, and we'd end up with 60 over 100. That would give us 60%. Okay. So here the solution is correct. Great job. And we'll mark this as correct. Let's move on to the next question. Alright, so question number 6. Okay. Alright, so the question is asking the inverse of the matrix. So we have an image. Just give me a second over here. Alright. So the image is as follows. So this is the question that we're asked. The inverse of the matrix as follows, where b is greater than 0 is one of these answers. So here, the inverse of the matrix 1 0 0 0 1 0 b 0 1, where b is greater than 0. And here we're asked for, we're given 5 options. So let me put this back here. So A is the inverse of this matrix this, or this, and we're given that b is greater than 0, or is it none of these questions? So we got to figure out what is the inverse of this matrix. So let's look at what the junior tutor proposed. So use the property of the identity matrix and its inverse. The inverse of an identity matrix is an identity matrix. Also, the inverse of b is the inverse of b due to the matrix being triangular. So A is the correct answer. So let's go through how we think about doing this. So one thing to note when you're looking at this question is the following. So some matrix A times the inverse of that matrix will give us the identity matrix. And what the identity matrix is essentially, let's say if we're working with a 3 by 3 matrices, we would say 1 1 1. This would be the identity matrix. So looking at this question, we have, so we're trying to see what is the inverse of this. So essentially we're trying to find what is a to the negative 1. So the inverse of this. So if we were to write this out here, 1 0, we know this is equal to a. 1 0 0 0 1 0 b 0 1. And then we'd have a inverse equal to in, which is just this. So when we're looking at the options, we can kind of just go through each option one by one and see which one works, and that ends up giving us this matrix. So let's plug in the following. So here we have, if we plugged in this one, let's say 1 0 0 0 1 0 b inverse 0 1, and then we want to solve what we'd end up over here. So to find the first component, we'll always do the row, so the row times the column, and so on for each component. So we say row 1 times 1 is just 1, plus 0 times 0 is just 0, plus b times 0, which is just 0. So we'd have just 1, so it would be 1 times 1 plus 0 times 0 plus b times 0, and we know the first term is just 1, so we write 1. And we do the same thing for the rest. So let's say 0 1 0 and 1 0 0, so 0 times 1 is just 0, so we'll say 0 times 1, and then plus 1 times 0 plus 0 times 0. So here we have 1 times 0 and then 0 times 0. So this just equals 0. So you do the same process for the rest as well. So we do the following. I'm not going to write out each one, but I'll say them as I'm going. So we'll say 0 times 1 is 0, plus 0 times 0, plus 1 times 0. So this bottom term is also 0. And then we go to this term over here, which is this row times this column. So 1 times 0 is 0, 0 times 1 is 0, b times 0 is 0. So we know this is 0. And the next term, we'd use this row times this column, and we can see that it's 1. And then the following will be this row times this column, and we can see that it's 0. And then the last column is really what we care about. So here we have row 1, 1 times b. We have, so here we have b to the minus 1. So I'd say b to the minus 1. 1 times plus 0 times 0 plus b times 1. You can see right here that this doesn't give us 0. Well, we're trying to say that this should be equal to 0 in order for us to get the identity matrix. So we can see that this cancels out to equal. This just equals so b to the negative 1, and then this cancels out, and we're left with b to the negative 1 plus b. And we can see that this should really be negative b for it to cancel out and become 0. And here we have this option over here, which has negative b, and the rest of the options don't have negative b. So if this was negative b, then we would end up with 0. And you would have satisfied the identity matrix, and you'd have 0, 0, 1. So here, this is the term that we're really looking at. In this situation, it would not be satisfied because it would be the negative 1 plus b. But if it was negative b, so I'll erase that here. Then we'd have negative b over here plus b would give us 0, and we get this term over here. And that would be our matrix, the inverse of that matrix. So this would be the answer, and in this situation, the answer is D. So looking back at the solution here, so here they selected the incorrect answer. So incorrect answer, solution is incomplete. Correct answer is D. And mark this as incorrect. Alright, let's move on to question number 7. Okay, so this question is asking us how many, one second, let me move this out of the way. How many feet are in a football field that is 100 yards? So here we're given the following solution by the junior tutor. So yards and feet are the units of length. So we have to use a conversion rate. Here they have yard is 3, foot is 12. How many feet are in a football field? That is 100 yards. So essentially, right here, 1 yard is 3 feet. 100 yards, so 100 times 3 feet is 300 feet. So they use kind of a conversion factor to answer this question. So essentially, how to go about answering this question, you do the following. We know that the conversion factor is 3 feet per yard, per 1 yard. And here we're asked what is how many feet are in 100 yards. So we would just multiply the conversion factor by 100 yards. And we can see that the yards, this and this cancel out, and we're left with 3 times 100. We'd have 300 feet. And that would be our solution. So looking at, so they provide the correct answer over here. So they also give some examples here for similar problems. So how much is 4 centimeters in millimeters? So using a conversion factor of 1 centimeter is equal to 10 millimeters. If we multiply 4 centimeters by 10, we'd end up with 40 millimeters. And then they go through another example, how many yards are in 12 feet. So we know that it's essentially asking for the opposite of this. So there's a third of a yard in 1 foot. So they multiply 12 by a third, and they end up with 4 yards. So correct answer. Great job. And we'll mark this as correct. Okay. So in this next question, we're asked terminal point calculator. So we're given the, I'm going to infer that we're given the following equation: x squared plus y squared is equal to 1. And we're supposed to calculate the terminal point of this given this angle. So the angle is 5 pi divided by 12. So this is question number 8. So we're given 5 pi divided by 12, and we need to know the terminal point. So looking at the Junior Tutor solution, we can see that they provide the correct conversion between coordinates. So x and y is just sine theta cos theta. So they do sine 5 pi over 12 is equal to this, using an identity, and they end up with sine 7 pi over 12. And they do the following. So they're using identities here. It's not necessarily useful in this scenario because you could just plug this into your calculator, especially if you're going to end up with a decimal place anyways. If you're looking for a whole number, you might do it differently. You might try to use these identities, but essentially what you would be doing here is essentially you'd say x and y equal to sine theta. Oh, sorry, this is a little messy. Let me erase that. Okay. So x and y is equal to sine theta cos theta. And we end up with, so if we look at just sine theta, so we're trying to evaluate for sine 5 pi over 12. We would just plug this into our calculator and we would end up with 0.97. So I'll double check this. Let me just grab my calculator. It's right here. So make sure that your calculator is in radians. So we have sine 5 pi divided by 12, and we end up with 0.9659. So this is correct. And then we have cos 5 pi divided by 12, and then this would give us cos 5 pi divided by 12. So 0.26. So here they do the right calculation. To explain what they're doing here, they're using an identity to make this conversion. So I'll actually go through that. So we validated that these are the correct answers. So this is the final solution is correct. But I'll show you what they're doing over here. So the identity that we're looking at is as follows. So if we had sine theta minus is equal to sine theta cos theta. I don't know what this symbol is called, but it just looks like that. Minus cos theta sine this symbol. Okay, so this is kind of the conversion that they're using to convert sine 5 pi divided by 12. And essentially what they're doing here is saying that sine pi minus 7 pi is equal to this. And if you were to go through this calculation over here, you'd end up with sine 7 pi over 12. So I'll go through this just to give you an idea. So here theta we're saying is pi. So I'll just write that up here. It will be pi minus 7 pi divided by 12. So theta is pi. So sine pi cos 7 pi divided by 12 minus cos pi sine 7 pi divided by 12, and then you end up with 0 times cos 7 pi divided by 12, so this is just 0, and then we have minus, so I'll just write this, minus cos pi, which is just negative 1, times sine 7 pi divided by 12. And so we know this cancels out, and we're left with just sine 7 pi divided by 12. So this step is really unnecessary unless you want unless you want to go further into the solution and try to get kind of a fraction for 0.26. But in this scenario, we're not really asked for that. We're only really asked for this solution, which we already validated. So we'll say answer is correct Great job. And we'll mark this as correct. So we'll move on to question number 9. So question number 9 is asking how many pints in a gallon. So this is kind of using the imperial system. So here we're looking at the junior tutor's answer. There are 8 pints in a gallon. Gallon is an imperial and United States customary measurement. The symbol gal, pint is an imperial measurement system. So that's kind of the conversion. So if you had, let's say, so we know that the conversion is 1 gallon equals 8 pints. So if you're asked, let's say, how many gallons is 16 pints, you would multiply by the conversion factor, which is 1 gallon per 8 pints. So you'd have the pints cancel out, and you have 16 divided by 8, which is just 2. So you have 2 gallons. So that's kind of how you'd use this conversion factor. Similarly, if you, let's say you had 20 pints, you'd use the same conversion factor, so we know it's 1 divided by 8. So 20 divided by 8 is just 2.5 gallons. So that's kind of answering this question and kind of just going through some examples on how to use this conversion factor. So answer is correct. Great job. And we'll mark this question as correct. Alright, let's go to the next question. Okay, so this is question number 10. Okay, so this is just an algebra problem. So 42 divided by 3 quarters. Sorry, 42 divided by 3 quarters. So looking at the junior tutor's question, so they have 42 divided by 3 quarters. They flip the fraction, multiply, and then they end up with 56. So just to write it out a little more clearly, so 42 divided by 3 quarters. So when you think about this, this is kind of a difficult way, like it's pretty hard to divide 3 quarters into 42. So the trick here is whenever you're dividing by a fraction, you just flip the fraction and multiply. So this is equivalent to saying 42 times 4 over 3. And then this is a little easier to calculate. We know 42 divided by 3 is 14. Multiplied by 4, which is what was left up here. So we had 42 divided by 3, got 14 times 4. And we're left with 14 times 4. So if we think about 14 plus 14 is 28. 28 twice is 56. And we end up with the correct answer of 56. So this question, this answer is correct. So great job. Correct answer. And we'll mark this as correct. Alright, let's go to question number 11. Alright, so just give me a second over here. Alright, so in this question, we're asked to convert 2.3 into a fraction. Let's look at what the junior tutor said. So here they split it up into 2 numbers. 2 plus 0.3. So, and we're trying to convert 0.3 to a fraction. So 0.3 is 3/10, 3 over 10. And we end up with 2 and 3/10. And then they converted 23 divided by 10. So this is kind of, they give the mixed fraction and then this kind of style of fraction. So if we had 2.3, so one thing I would do is make it to base 10, so we can just multiply top and bottom by 10. So if we had 10 over 10, which is just 1, so we're not really changing the number, we'd end up with 23 over 10. That's kind of a way to start off how to write out the fraction form for 2.3. You can split it up as well, but I like doing it this way. And then you can kind of convert this. You can see that there's a 23, so we know 20, 10 goes into 20 twice, so we know it's 2, and then we're left with 310. Because there's still a 3 over here that's remaining. So this is kind of a way to think about how to convert it into a fraction form. So we'll mark this question as correct over here. So great job. Correct answer. Alright. Okay, I believe this is the final question, question number 12 for this session. So 12. Okay, so here we're asked for the derivative of e to the 2x. So, looking at the junior tutor solution, derivative is the rate of change in the function's variable. Newton introduced a notation for the derivative of function f. This explained the symbol for the integral and wrote the derivative of function y for the variable x, both of which are still in use. So here we have e to the 2x, an exponential function. Derivative of the exponential function is the same times the derivative of the power of the exponent. So difference is a derivative of power of exponential is multiplied with that exponential function. So we can see here the derivative is e to the 2x times the derivative of 2x. So usually I think about the derivative of the outside. So if we were to take the derivative, sorry, let me erase that. So the derivative of e to the 2x, I think about outside as this, and inside is the exponent. So I would do the derivative of the outside, which is just e to the 2x, multiplied by the derivative of the inside, which is 2x in this scenario. So we know derivative of 2x is just 2, and we end up with 2 e to the 2x. So regardless of what the exponent here is, even if it was, let's say it was 3x squared, you would do the same thing. You'd say e to the 3x squared times the derivative of 3x squared, which is just 6x. And you end up with that solution. In this scenario, we're asked for this, and we end up this derivative. So looking at this, so they end up with the... So they say 2e to the power of 2x. So this is a little bit off. It's just e is the power of 2x, but the 2 is not. 2 is just multiplied out front. So I don't know why. So this is a mistake in the solution. So then they provide another example with tan x. Let's not worry about this one for now. And we're giving ln 1 over x. So here the question only really asks for e to the 2x. So I believe this is just a typo. It could be just a miscalculation, but the correct answer here, so incorrect, the correct process, incorrect final answer, correct answer is 2e to the power 2x. The 2 is not raised to the power of 2x. Okay, we'll mark this as incorrect. So let me just double check something. Yeah, we'll mark this as incorrect. Okay, well, thank you for tuning in to this session. Hopefully you found this session helpful. If you need more homework help or any tutoring needs, you can always visit the link in the description or visit OneClass.com. Videos are uploaded on a continuous basis to this channel, so you can also subscribe to this channel for any homework help. I'll see you in the next video. Bye for now.